Uh, Today we'll talk about nested quantifiers and about contraposition. So let's consider the following example. Our domain will be Z, and then we want to check if the following two statements are true or false. And let's look how these statements look like. So inside we have just statement or equality x plus y equals to 0, which is here. And then the way it is constructed, so there's no really propositional structure in it, it's just a basic statement. And then from that statement was combined with the quantifiers there exist y. And that made another predicate formula. But then after that, we also got for every x. And that's what actually makes this situation where we have nested quantifiers, because we have one quantifier and then the second one referring to this formula that already involves the first quantifier. So the main thing here is to see how the interaction between these quantifiers happens, particularly how important is the order of quantifiers. So generally, and that's very important, and influences actually the truth value of these statements. So first one, in A, since outside the quantifier is for every x, in order to show that that formula is true, we need to test it for each single x from the domain Z. So generally, in A, we need to test the following. When we choose x to be 0, we need to ask, is there a y such that 0 plus y is 0? And when x is 1, is there a y that 1 plus y is 0? When x is 2, is there a y such that 2 plus y is 0? And so on. And also for negatives, if x is -1, is there a y such that -1 plus y is 0? And so on. So generally, when we ask you to decide if this sentence is true or false, we are asking you to check if all these sentences actually are true. So if we have a way to test them all, or test them all in generic way, then what do we say? The answer for this one is yes, because that's green stuff inside, because we need a witness y. 0 plus 0 is 0. What about here? Yes, because 1 plus -1 is 0. And so on. What about here? Yes, because -1 plus 1 is 0. So generally, we can test all these sentences and then give the answer, provide the answer that this statement is true. All right, let us notice that for each of these existential statements we needed to provide a witness. But then when we changed our x, we also changed our witness. So in the first example, in the first line, the witness is 0, in the second one, witness is -1, and then in this line, the witness is 1. So basically, we are allowed to change the witness, and then each time when we change x, we are just asking for another, for the same or a different witness, one way or the other. Witness changes, we sometimes say that actually we have a witness function. And the statement is true. In part B, we also have nested quantifiers, but now this nesting was done in a different order. So existential quantifier is outside, and then universal quantifier is inside. And you will see in a minute that this is actually a much stronger statement. Why? Because what we are asking here is outside to provide a witness up front, the witness that will work for each x simultaneously. And that's of course much stronger demand. So basically what we will have, let me see what camera is. So we want the following. We want to find a witness C. We need a witness C such that for that C now, for every x plus C 0, which means we want what? That 0 plus C 0, 1 plus C 0, 2 plus C 0, and so on. But that's obviously impossible, because at the same time C should be 0, and C should be -1, and C has to be -2, and that's impossible to find a number that meets all these requests. Once again, why? Because we cannot find a witness that will serve all these equalities. So that's why this time we will say that, that this statement is false. So this example tells us that it's sometimes very sensitive when we change the order of quantifiers, and the order of quantifiers does matter. Generally, when we try to interpret it, what do? We interpret the outside quantifier first, and then sometimes that breaks the sentence into millions of individual sentences, or infinitely many more precisely. Or when you do it with existential first, then we get one sentence, but then of course that one later on, if the universal count, breaks into infinitely many sentences. So that's how you need to address nested quantifiers. That's one thing, so address them from outside inside, and then the other thing is be careful not to switch the order how they are constructed. So generally it's always outside quantifier refers to everything that's inside the sentence, if that's what parentheses say, and that's how it should be interpreted. All right, let's do one more example where I want you to pay attention to the way we record the sentences from in everyday English, and the other way around, from everyday English into predicate formulas that involve nested quantifiers. Here's one example from the notes. It says, rewrite the sentence in everyday English. So that's example 222. And the sentence is, for every x in R, there exists y in R such that x plus y equals 0. That's actually the same sentence that I started the discussion with. So how do we express this in everyday English? We would say the following. We just say what's outside. So for every real number x, and then you don't have to rush it, you can just copy the rest of it. This is not stylistically very nice, but this is just work in progress. There exists y from r such that x plus y is 0. And then we translate the rest of it for every real number x, there exists a real number y, so that their sum is 0. Of course, we can say this even without variables in a more natural sentence, and that one we usually when the sum of two numbers is 0, we say that they annihilate each other. So we can say the following for every real number without giving them name. There is a real number which annihilates it. How? Or we just say, again, we invented some simpler way to say this in mathematics. That number is also called opposite number. Every real number has an opposite number. All right.